So these MAC addresses, though, are going to be used, as I said, for the communication inside the local area network. And different types of MAC addresses are going to determine different types of communication. So we can have what is known as unicast communication within that local area network. Unicast communication says, I want to talk to you and you alone. So in that case, the source MAC address belongs to this specific device here. The destination MAC address belongs to this device here. So the frame that I create has a source of this PC and a destination of this PC right here. It's called unicast communication. And with unicast communication, we can use many different protocols, meaning one-to-one communication. Telnet uses unicast communication. FTP uses unicast communication. So does HTTP. Our ARP reply messages are unicast in nature. Our DHCP offer messages are unicast in nature. But there are other ways to communicate as well. For example, there's broadcast communication. So with broadcast communication, we are sending a frame from this device, and we want that frame to go to everybody in the local area network. That's right. I'm sending it from this device, and it's going to everybody in the local area network. How do I accomplish that? Well, there's a dedicated MAC address for broadcast communication. So the source MAC address will be the sender. So this device puts its own MAC address in the source field. But who's the destination? Everybody. Do you know the destination MAC address that's used for broadcast communication? If you do know it, shout it out right now. Yell it out so everybody can hear you. Yeah, okay. It is F, 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 colon, F, 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 colon, F, 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 F. It's 12 Fs. 12 Fs. That's all it is. So the source MAC address is this device, and the destination MAC address is all Fs. That's right. And that means it's going to go to absolutely everybody in the broadcast domain. Will a broadcast frame ever cross a router? No. Because remember, routers are the boundary points of broadcast domains. So the broadcast will never cross a router interface. So that stays within the local area network, this broadcast. So we have services like DHCP Discover messages and ARP requests and some routing protocols that use broadcast in order to communicate. So for example, DHCP Discover. My PC right here boots up first thing in the morning. Needs an IP address, subnet mask, a default gateway, the DNS server addresses. How is it going to find a DHCP server in the local area network? Simple. Send out a DHCP Discover message. Source it from yourself, but send it to everybody. And then only the DHCP server responds because it's a DHCP Discover message. Nobody else cares about it. Just the DHCP server says, oh yeah, I'm a server. I'll respond to you. And it'll respond back with what type of message? Remember what I said, a DHCP offer is unicasted. Look at that. So when I'm trying to find the DHCP server, it's broadcasted. But when the DHCP server responds back to me, it's going to be unicasted back because I provided them with my MAC address so they know how to get back to me. But we also have multicast communication. Multicast communication is a more efficient method of talking to multiple devices than broadcasting is. You see, broadcasting affects everybody in the local area network. Absolutely everybody. Goes to everyone. That's bad. Because what if we had 200 devices in that local area network? That means all 200 devices are affected. And if all 200 devices all broadcast, then that means we have 200 broadcast. Yeah, you see what I'm saying? That's a lot.